the new Zoom thing. We don't. Hello.
Welcome everyone to the Flux Dev Meeting.
So
Everyone,
yeah,
we started a little bit earlier. Go, Mateus. We were discussing.
yeah, we were in the
No,
middle of discussing Spiffy with Flux.
cool.
Uh, yeah, and I hope with the new Zoom thing, more people can start a recording. um, so yeah, as I was saying, we want to grow that end-to-end test in the module to test the whole thing. It already proves that one of the challenges is conquered, right? Which is the using this PVCSI driver in the Flux pods. So that is good. Uh, and then so when we have everything released and the Flux like code on top, we can improve that into that test. So that's something that will happen in a long time from now. Um, okay, how does the integration look like? As I said, from an integration perspective, all we need is the Go Spiffy library, right? It's the whole point of Spiffy. Spiffy is a set of two or maybe three gRPC services, and they have this library that has the generated Go code for the gRPC services and probably some things on top to make some things easy. Like, for example, I think they handle, if you want to use the X509 PKI from Spiffy, right? The X509 SVID, then it has helpers to plumb that
Mm,
into the transport for Go when it gets,
nice.
which is probably something we use that. So in Flux 2.10 roadmap, our ambition is quite big. It's let me read it here. It's four things and a few other issues that are covered by these four things. So I have the roadmap here. Maybe I'll share it.
Yeah.
Share. Share. So 2.10, uh, this is what we have planned in terms of beefing for 2.10. Quite ambitious. Uh, we want to use JWT JOT SVID for exchanging credentials with the things that support JOTs for exchanging credentials, which are OpenBall and Vault, um, just like we did in Flux 2.9 with where the JOT comes is the Kubernetes Service Account Token in this case. So in 2.10, we'll have a new JOT to exchange with everything that accepts one, which is OpenBall, Vault, AWS, Azure, and GCP. We can also exchange X509 SVID as well if your company has some requirement that you need to use X509 instead of JOT for whatever reason, because it has proof of possession, right? Like, I don't know. Then we can do that for AWS and GCP only because Azure does not support it. Maybe OpenBow does. I don't know if it's a matter of opening the connection or really just doing the login. We can look into that. Yeah, so this is the first half of Spiffy integrations, which is about exchanging the credentials that Spiffy give you with the credentials that with the things that accept them. And the other half is subdivided into things, these two. The first one is using JOT SVID directly with things that accept OIDC tokens directly. For example, Kubernetes accepts that. So customization and hand release, talking to remote clusters, this is essentially the same feature we already have, which sends a service account token again. Instead of sending a service account token, you can send, if your org is into Spiffy, you can send a JOT SVID instead of a Kubernetes service account token for Kubernetes remote clusters. And the same for OCI registries. So for example, ZOT. ZOT for a while already supports OIDC tokens without exchange. Like you can just on every call send a bearer token that is an OIDC token. And again, we're going to support, that's one of the things that we don't have yet in Flux, which are these two. So we can send service account tokens for container registries, for example, ZOT. We're going to implement that. That is not that these features here are not spiffy, but we're going to do both, right? Like in 2.10, we're going to send JOT SVID and service account tokens to container registries. And the last thing, which is something I added as an idea when I was updating this roadmap for the first time. This was the first time I thought about it, but it makes total sense. Is we can start supporting SPIFFE PKI X509 SVID for TLS, right? And in TLS, today we only support secrets. We have spec.cert secret ref everywhere. So you can provide a CA to authenticate the server. You can provide the client cert to authenticate Flux. And instead of requiring a secret, Flux can now use short-lived X509 SVID for TLS as well. So those are the integration points I'm aiming for.
I like
And
this in TLS stories. It's really good.
right, it's
Yeah,
interesting, right?
this is so many things. Go, Eric.
Yeah.
Yeah, just just this question, the SPIFFE ID, will that be based on the Flux resource in this case with
Yeah,
Flux?
so that's a good question. Spire does not have support for deriving. I have an issue, a feature request I opened for deriving the SPIFFE ID from the object reference, right? Like the name, the type, some, I don't know if there's use case for using the UID. I don't know, maybe some security obsessed people would want that. But yeah, that's something that is being discussed. They like the idea of facilitating uh, generating SVIDs, SPIFFE IDs for things because it has been a source of pain. Like it's hard to use Spire. Like it's complicated, honestly. So I am trying to make the UX better with regards to that. I think with the chart, with the things I'm gonna do in the chart, it's gonna cover most of the complexity, but there's still this part that you just brought up. So initially, the only thing you'll be able to use as a Kubernetes resource for the integration would be the cluster static entry, CRD, from Spire Controller Manager,
Yeah.
which is a very simple way to just say, give me an entry with this PFI ID, this parent ID, and these selectors. So this means you have total freedom to decide the shape of the PFI IDs. Like what the implementation does, like what the attestation method for Kubernetes Inspire is like, okay, I verify this reference. For example, you send me a reference that says name, namespace, type, and also UID. When you send the UID, maybe Flux will do that because Flux will know the UID at the point of getting the credentials. So I think we'll do that. It checks like it locates the object through the name and then it checks if the UID in the object that it fetched matches the one that I passed on the RPC call to the broker API. So yeah, I guess this answers your question about the SPIFFE ID, right?
Yeah, you're probably seeing the standard ones for service accounts, which starts with the trust domain as the host name in the SPIFFE URL, and then you have slash namespace slash, and then the name of the namespace slash SA slash, and then the name of the service account. I would expect something
Right.
similar in this case.
Yeah, so that's for workloads, right? So I guess maybe I'm kind of delaying into entering how the integration actually works, and that will probably be answered. So broker API, right? Like, okay, Kubernetes did not separate the concept of a workload and a workload that acts on behalf of objects, right? That the broker API solves exactly that problem. In Kubernetes, both workloads, which are pods, and everything else can have a service account name field, like a spec.service account name field. And we implemented that in Flux, right? Like we have spec.service account name both for talking to the Kubernetes API in customized controller and Helm controller, and also for workload identity in cloud resources. In the case of SPIFFE, which is only for workload identity, right? They introduced broker API to make the separation of these concepts. So Flux is a workload. It will use the workload API in SPIFFE to get a credential for itself in the SPIFFE realm. That would be an X509 SVID. So the first integration point that Flux will do, the first library I'm going to write in the package repo in the auth submodule is workload API. It's like how each controller in Flux can get a credential for itself in the SPIFFE realm to represent itself. That will be what you just said, Eric. That SVID is going to be like it can be the service account, right? Like the namespace and the name of the service account. It can be, but it can also be defined in other ways. Like it can be like it's possible to just say, hey, this is source controller if you have only one in the cluster or something like that. I think you have like you're not really tied to that format with service account. But either way, it will work because okay, once Flux so this will be like this. The SPIFFE CSI driver is mounted in the Flux pod. There is also the environment variable that the GoSPIFFE library uses. You also have to set that on the pods because that points to the socket, the UDS socket that the CSI driver will mount. And boom, like this is a vanilla application in Kubernetes that consumes workload API from SPIFFE. Okay, now you use the X509 SVID, which is an MTLS bundle, to open a connection with the Spire agent to consume the broker API, which a broker is exactly this. It's a workload that is entitled to act on behalf of other things, like a workload or like a Kubernetes object, right? So Flux will be a broker. And then in the broker API, that one it can be over TCP. It's one of the initial reasons for them to design the broker API was designed to support TCP. And in Flux, we're gonna have the CSI driver. We're gonna have the environment variable of GoSPIFFE for the path of the socket. And we're gonna have a flag in the controllers with the address of the broker API as well. So it's gonna be like 3 inputs, right? Like one configuration and 2 obvious configurations. The CSI driver and the environment variable with the socket path are quite standard, plus a flag with the endpoint of the broker API. That one can be on our side, we can support UDS and TCP for that. But an ideal deployment would be so I'm working on like on the chart side in SPIFFE. My idea is to have a top level chart that allows users to deploy the broker API agent, Spire agent, serving the broker API multiple times in the cluster. For example, in this Flux system namespace, that's currently my ideal way to do that. Like you can. So far, the projects that are driving the use cases for Broker API are Istio and Flux. Istio was like somebody from Istio has been talking to Spiffy for a long time for something like this, and Flux came second. So, but I don't know. Let's say Argo also does that someday. Like every project in your cluster that uses the Broker API, except Istio, like the ones that are using for object references like Flux, I would recommend to have one Spire agent pod in that namespace. So one in the Flux system namespace and one in whatever other cluster add-on you have, infrastructure component that you have that wants to use the Broker API. Deploy a Spire agent pod for that as well. And this is good because you have the guarantee that that pod will be there in the Flux system to serve traffic only from the Flux controllers. Cool, go ahead.
I was muted. Why isn't the broker API provisioned as part of the CSI driver? Because it's TCP and not you don't need
Yeah.
a socket.
Exactly. Like, I mean, it supports both things. So, for example, Istio will use the broker API via UDS. Like, they have a requirement of they are like a workload that runs as a daemon set. Like the Spire agent runs as a daemon set, right? So,
Yeah.
And they need node locality. Like they're gonna run in a mode where the broker API will only serve Istio ztunnel over UDS, and the pods they can reference must be in the node as well. So the three things have to be on the same node. The Spire daemon set pod agent, the Spire agent that runs as a daemon set pod, ztunnel, and the pod ztunnel is asking an SVID for. They will use the broker API like that. So it's basically a matter of enabling a new endpoint in the daemon set pod that Spire agent already is, right? For us, it's a new deployment. It's a deployment. It's not a daemon set because it's a TCP endpoint. So and it like introducing a service for a TCP port in the daemon set kind of introduces some problems. That daemon set can be running in the host network, for example. So it's not ideal to serve the broker API over TCP in the daemon set pods.
Yeah,
Right.
but
No, but
yeah, go Eric. Sorry.
I mean, Flux is supposed to use its workload identity to authenticate towards the broker API endpoint, right?
Yeah, like Flux will use Spiffy in two ways, right? Like it will use the workload API to get an X509 for itself and use that to authenticate to the broker endpoint.
Exactly. So I mean, one of the ideas behind Spiffy and Spire is to have open endpoint. I mean, open things. It kind of recognizes you from what you can present, either someone proving that you are who you are when using the CSI driver. The agent and the CSI driver uses the Kubernetes SPI as a reference to only acknowledge the identity that's actually the pod requesting the identity and the credentials for that identity. But in case of the broker API, you will already use the workload identity of the Spiffy controller who wants to get some other Spiffy credential for a workload or for a Flux resource.
Yep.
So in this case, I think the broker API could be kind of an open service. I don't see why it must necessarily be locked down completely.
Right. Yeah, yeah, exactly. The chart I'm proposing upstream, it can support both ways. It can be a single deployment in the Spire namespace that serves the whole cluster, all the cluster add-ons and infrastructure components that want to act as brokers, right? Yes, you can make this choice, but you can also make the other choice if you want. Like if you want to deploy multiple Spire agents serving the broker API for each component, you also be able to do that. I think it's nice because it's also maybe like I don't know if controlling the traffic that the broker API will get like becomes simpler if it's
It,
just
it's nice
there's
to
also
have the option
network
of locking
namespace.
it down network-wise as well, of course.
Exactly. Network
It's good
policy.
practice to allow that, but
Yeah.
I'm more curious to how in our example we have Spiffy and Spire running on-prem. At some point we need to authorize Flux to actually be a broker API user in a sense that we must authorize Flux to use the broker API. It's like we authorize some components to do token requests for
Yep.
like
Yeah.
anything in the cluster.
That happens in two layers. So the one layer is static configuration entries in the Spire agent in this deployment for serving over TCP. So the Spire agent has configuration for the agent and has configuration for the Kubernetes workload attester plugin. Those two configurations, the agent and the plugin, both will have a list of brokers, which are SPIFFE IDs of the workloads. So if you already have a SPIFFE, let's say it's in the format you said, right? Like Flux System Source Controller, for example, a SPIFFE ID like that, you're going to put that SPIFFE ID in the configuration of these two configurations of the Spire agent. So this is static configuration. One is to allow, like the agent side is to allow, these brokers are the ones allowed to use the broker API in this agent. And for each one, you have to declare which reference types. For Flux, that will be Kubernetes object reference. There's two. There's workload PID reference, Istio. Actually, Istio will not even use PID. But anyway, there's two. Workload PID reference, Kubernetes object reference. For Flux is Kubernetes object reference. So you're gonna put the Flux controller's PFIDs there, allow them to use the Kubernetes object reference over TCP. But the chart will make that easier. And the configuration on the plugin side is to say that is the one that connects with RBAC. So you also need to, so besides the static configuration of the Spire agent, you also need to add RBAC. And the RBAC in this case will be the SPIFFE ID will be the Kubernetes username. You know, when we do impersonation that we have username and groups everywhere, Flux UI does that, right? Like it extracts from your OIDC token, your username and groups. It's the exact same mechanism, but no groups. And the username is the SPIFFE ID that you got over workload API. So the ones for the Flux controllers. So those are the two ways you're going to need to do this. And in the chart, I plan to make all of this easy. Like you list very easily the brokers, like SPIFFE IDs for the Flux controllers, for example, and in the ham values, and then that will transform into the configuration, the two configurations for the agent, and in RBAC as well. Like I'm gonna put an RBAC knob there, and you're gonna say source controller is allowed to everything under the source.toolkit.fluxcd.io, for example.
Cool.
But I
That's how
think
it's.
to Eric's point, it was like, I already have my infra. I don't want your chart. So
That
we
was actually my
need,
next question. Like in our case, we install Flux a bit later in the process.
You install, do you have Spire running inside the cluster, first of all?
Yeah, in some clusters, yeah. Not in all, but in some of them, yes.
Do you use Spire Controller Manager?
Yeah.
Cool.
We also
Well,
use the shard, so I mean, if you make the shard perfect, it should be easy
yep,
for me to adjust it with
if
the right coordinates needed to be able to use it with Flux.
you're currently inflating the Spire charts,
Yes.
Yeah, you should be able to do the same for the new one.
Yeah.
Yeah.
Oh yeah, you do Helm template and then you apply a Flux customization on
We
top
do.
of it if
Yeah.
if you need to harden it or whatever. Um, oh yeah, sure. So we can onboard this chart and make it easy for everybody to deal
Yeah.
with. Like the amount of configuration is insane, right? But in the end, you are configuring identities everywhere, and you need to pin them
Yeah.
down to everything that you
Yeah.
can. Like I
So
think
I'm trying to
the
put as much as I can inside the chart to
yeah.
make that simpler.
Yeah,
Yeah,
I
I
mean,
mean,
we
it's
need to build a config API through hand values, which is not great, but it is what it is. It's the easiest
Yeah.
solution
yeah.
to ship
Yeah.
something fast.
I mean, it's for sure we have to support both the setup that we have, where Flux is arriving a bit later in the process, the cluster is already running, but also what you had your main focus on, like the bootstrap problem. What happens if you want to bootstrap your cluster with Flux,
Right.
which needs to come with this already set up? That's also very important. So
Yeah. So in
Yeah.
this is what Matteo said earlier, but it's only in this Terraform stuff. That not everybody's on Terraform and so on. But there a procedure that can be used outside of Terraform and so on.
Yeah.
There is nothing very special. What's special
At the end
there
of
is
the
the
day
bash
is
script. It's a
yeah,
bash script
yeah.
that does a bunch of very smart things with all our CLIs mixed together. But we actually solved the chicken and egg problem to orchestrating jobs that run in cluster with identities to Bootstrap Flux itself, and then the job is a throwaway. And we designed the system as a truly one-off. Bye bye. I don't care about its idempotent. It will never override if the cluster is now fully bootstrapped. And I think that that kind of procedure now with this integration, it feels like so much complexity brought into the whole thing.
yeah.
It has to have that good UX where you are being pointed fingers of you only said these three things and you are good to go. And it should really work in the right order as well, right? The order
Yeah.
is so important, especially at things
Yeah, I
that
mean
run before boot Flux. Is like that's where those hooks that we've built are
yeah.
yeah.
Yeah, I mean essentially it's simple. Spire has to be installed before Flux. Like Cilium, even in a cluster
Like
without
the C
CNI.
like a CNI wanna cluster
Yeah.
without any CNIs or not even
Yeah.
proxy, right? Cilium replaces that as well.
But did we
Um,
investigate that fully? That it's not possible to kind of mount a CSI volume without the CSI driver already being installed. That would be very nice in Kubernetes if you could say to Flux when you install it, hey, mount this volume from using this CSI
I
driver.
think I tried and I did
Okay.
not succeed.
I also tried it, but I was wondering, is there a trick to make that happen? Because that will make it so much easier.
but we would need to implement everything in the driver, right?
Yeah, but then the volume will just appear in Flux when the driver is installed, some point later after Flux is running. It will
Oh,
be
later.
it will
Oh,
be more
okay.
like the web UI is working now, where kind of
Yeah,
Flux
it
is
waits for
prepared
the
to spin
configuration.
things up, but it's delaying until it can find what it needs.
Yeah, I
Oh
can try
yeah,
that
in
again.
that way, yeah.
Yeah,
I remember when we had this conversation at KubeCon, that was the first thing I tried. Like, can
yeah.
I do what Eric is saying? And
I
then
also tried it, so I know, but there are so many hidden parts of Kubernetes. I was just wondering, might there be an option, a feature hidden somewhere that could make it kind of optional?
yeah.
Yeah. So let's resume on Spiffy and Spire integration. So we want to make this as seamless as possible because it's very complicated to integrate, right? So that's priority one. We need to nail the
The
UX.
UX.
Yeah, if you have to spend 2 days to figure stuff out, is not good, right? And second of all, we need to offer people a way. In my opinion, I think this is very important offer people a way to completely isolate the broker in the Flux system namespace and not rely on a global one. The Flux system namespace is already shut down with network policies. No other namespace can reach into it. It's like
Yeah,
our own little domain.
exactly.
So I
If
think we
it's
should.
there, we don't even need any, like what we have in network policy right now is
It's
already
enough.
enough to do
It's
the
yeah,
lockdown. Like we
because
don't even do
this is how
anything.
we design the thing, right? If you drop something in Flux system namespace, it's trusted by the Flux controllers, and you shouldn't get to it at all from outside, right? So that's why there is that network policy that drops everything from outside. It only allows inside communication. But okay, so we should be able to seal it off completely in our namespace, but we should also be able to say, I don't want to deploy this new thing in the Flux system namespace. Here are the docs on how you can connect to the outside, right? So you need really good docs for a shared cluster-wide solution, which uh, is not something that we have in our own namespace. And then it's up to the cluster and needs to figure out the network policies and access control to that other broker. But beyond that, like let's say we ship everything in like this, right? And we are now able, let's say we go MTLS. And now we are now able to go MTLS from the Flux controllers everywhere, but not between the Flux controllers. Like when customized controller talks to source controller, it will still go over plain HTTP, even if both controllers, in theory, if they are connected to Spire and if they have the certificates loaded, they could, for talking to everybody else, they could use them to talk also to each other,
Good. That's nice.
right? But there is now the chicken and egg problem, right? You need, for the first thing to happen, like for that Helm release to be reconciled or installed or whatever, you need Helm controller to do it, and Helm controller needs to talk to source controller. And if Helm controller deploys the thing that makes us being able to connect to the identities, then it's the chicken and egg problem, right? So the only way to solve this, we need is like pre-setup of
Yeah. Yeah,
before
what the
Flux
module
that
does and the idea
yeah.
behind it as well, right?
Yeah,
It's
I
not
mean,
Helm controller installing those things. It's something else.
yeah,
It's a CLI, it's whatever, right?
yeah, maybe we should build it into one of the CLIs, the whole procedure, right? And make
Right.
it more accessible. But
Yep.
the idea is if we go, let's say in 2.10, we manage to get these TLS identities into Flux for talking to outside entities. I think for 2.11, we should really aim at Flux
Internal.
INSA internally should also be able to use these identities and have like, like lots of people are saying, oh, why isn't it customized controller connected to source controller over MTLS? Right. We had like this recurring, um, desire from some users. I don't know, every 6 months, someone brought this up, right? They don't necessarily trust the network, uh, the firewall behind the namespace, saying they want MTLS, because I think it comes from, oh, someone has access to the node and can sniff the traffic. And my response to this is, yes, okay, so what? Is the repo content? You shouldn't be having secrets there, man. I mean, why are you putting secrets in Git? Like, if everything should be, if it's a secret, should be encrypted, right? So if someone sniffs your traffic and sees a Kubernetes deployment, it shouldn't see the actual secret mounted in the deployment if that's in Git, right? So I don't think that traffic between customized and source control is sensitive. Eric, am I right here? Would you consider this traffic I don't
I
know.
wouldn't consider it sensitive, but at the same time, someone are very obsessed of protecting in multiple layers. So to some point, I agree with them that the namespace firewall is not enough.
I
Yeah.
think this doesn't, it's not a matter of opinion. It's like a matter of what certifications you need to check the box for.
Right. Yeah.
It's-
Of course. I
yeah.
mean, because it's the other thing. Like if someone is actually sniffing traffic on your nodes, if it's there, they can get all that YAML without having to sniff Flux. If you are that deep in the Kubernetes nodes, come on, man. Like, why would you even spend time wasting time sniffing Flux? You should be doing many other things because now you can gain cluster admin. And do whatever more than just niching traffic. So from a red team perspective, I think like once you get into that situation with Flux, is like you are in a very very worse place, and Flux is the least of your concerns. The Flux traffic, I mean. Uh, but right, in order to check MTLS everywhere, we need the MTLS everywhere. So if the SPIFFE integration can make this happen without tons of extra configuration, it will be ideal, right?
Yeah, because like it's basically is the this problem is reduced to the bootstrap problem. If the bootstrap is good, then cool. On startup, every controller can subscribe to the stream RPC for X509 SVID, and their internal like when we start, hey, here is the address of source controller, customized controller, then we initialize that connection using the facilities from Ghost Spiffy, consuming this stream of bundles.
So there are
So
two things that happen. One, customized controller and helm controller, they have no idea where source controller is because source controller can be sharded or whatever. So how source controller is responsible for advertising its identity inside the cluster, and it does it in the artifact
right, in
sub-resource, right?
status artifact URL, yeah.
Right. So when source controller publishes an artifact, it says, this is the artifact, this is the digest of the artifact, this is how you do the checksum, and this is the algorithm from the checksum. And here is where you can get the artifact. And this is the exact address of the shard of source controller, whatever, where it is, right? So customized controller has that information. I need to access this endpoint, knows exactly what endpoint it needs to access, and then it should use the cert to make the call. Even if the address is HTTP whatever, source controller whatever, you should extract the source controller address from there and do a MTLS connection.
Forced
If that future
MTNS
flag
connection.
is set, like yes, we have SPIFFE, then we flip everything without having to rewrite all the artifacts in the cluster to move from, I don't know, HTTP whatever
HTTP to
to
HTTPS, right?
yeah, rewrite all that stuff. Like we should have like, okay, it doesn't matter the protocol, we now use MTLS because this is what the flag tells me to, right? And we can flip all of Flux to now MTLS, and people can be happy and check the checkbox. Yes, we no longer have HTTP, plain HTTP traffic inside the
We
cluster,
have
right?
Spiffy PKI, the
Yeah, it's
best.
like
It would be even better if we could use MTLS without relying on having Spiffy or Spire installed. If that was possible.
yeah,
I wish there was
I don't
something in
like that idea.
Kubernetes.
I don't like that idea at all. A lot of people say like, no, Flux should roll its own. Yeah, sure. I'm going to rebuild. I'm going to ship my
Cert
own
manager.
CS. No, Flux should install Cert Manager, so that's out of the
I
question.
know, but you're re-implementing Cert Manager in Flux.
Yeah, and probably even more because Cert Manager does not talk to other services through its own certs, right? It's like Flux is a mesh, Cert Manager is just Cert Manager, right? Trust Manager it's its own thing, and so on. Like Flux has to do all these complicated. It's like rebuilding Istio, right? Then I have to have policies of my own between
Yeah.
source control and whatever. Right?
But
So
now
it's,
you get the cluster trust bundle from upstream, which will solve the trust issue
yeah. So I've
very
been
nicely.
looking into that. Someone created a controller that you can say, oh, listen to these pods or whatever, and create some annotations for, kubelet to mount the cert in the pod. So, and I think you can enable this in Kubernetes today. I think it's beta. It's
Yeah,
a,
in
it's a
newer
feature
versions you
game,
can. Yeah.
right? So you can actually now get that cert, and Flux then does not have to layer anything to use the static, to do MTLS with static certs that are not XOVs, not all the nice things, advanced things that Mateo says. Like, just give me the cert. I want to talk to this other entity. Buggy. And that, I think, it's an attractive solution to solve this other problem where, hey, I don't have SPIFFE. I don't use at all. But I have this requirement on this edge cluster that sits in a field somewhere. I need MTLS to, as Mateo said, cross-check my security, whatever, SOC, whatever it is there, right, that you need to do. And for that, we could, rely on Kubernetes alone, say, hey, give me a cert. We load it with the Go standard library, and we do Go HTTP client loads client, server loads server, at Bootstrap, at process start. I was, looking into this, but I think we should really add it to the roadmap once this gets enabled, right? Once there is a Kubernetes release, I don't know, at KubeCon that says GA this feature, then definitely I think Mateo will look into it and it will figure it out immediately, because it's not as complicated as what we are building now. It's way more, right? Mateo is like, you have the cert, and from there it's like a piece of cake compared to what we are doing in
It's
this
beefy. We
version.
had to invent a new standard.
No, but I mean, the local solution is so much simpler. I mean, the Flux component to talk between each other, that's a simple thing compared to what Mateus is trying to solve with SPIFFE, because that's more
All the
like universal.
other,
Yeah.
yeah, but
Yeah, that could be done today, actually. Like the internal traffic with SPIFFE, that actually could have done. I guess we just didn't have the idea, right? Like, it's could have been done a long time ago.
We don't need it, just to say before you start implementing it. So we have no need for this, but I can understand the users that want to have this feature. I can understand them.
Yeah, so we did have, like, there are not tons of users that really want this, but a couple, right?
Yeah.
And it's something recurring. Like, since years, this discussion comes up, and I mean, if we do SPIFFE for this complex connectivity outside, talk to all the other sources, why not do it for us as well? And if we can just mount certs given by Kubernetes, even better, even simpler. Another feature gate, use native certs or whatever, and at startup we read it, and I think it's a symlink or something. You have the Go watcher. It will tell you when the cert change. I think it's like mounting a secret, right? And
Yeah.
the secret is there are two symlinks, and you have to go through both of them to get the file. And there is a Go package used also by Kubernetes that I also used in Podinfo to do this from Go, and it's really easy, instant to detect when it rotates. I don't know if you do this in Cell Manager, but
Yeah,
there
we're
is,
using the Go library to do all the TLS stuff. So yeah.
no, the library to detect when the chain of symlinks changes, so then you can swap the cert in your requests, like
I don't
hot
think Cert
reload.
Manager itself is using it, but I'm aware that it's used
Okay.
in a lot of other
Yeah.
operators which are using Cert Manager, of course. Yeah.
Yeah, because you need to, like, without interrupting the connection, Like you process all the in-flights, you mount the new cert, and all the new ones stay there, and the old ones you wait for the old ones to clear. So it's like really nice and no disruption to the network. We
That's
don't
cool.
even have to do this in Flux because you have retries everywhere. You can just say,
Yeah.
oh. But yeah, Mateus, I think we should definitely add this to somewhere, an issue
I'll add to
to
the
look.
RFC. I'll add everything, like everything in the roadmap is in
Oh,
the
right,
RFC.
to the
Yeah,
RFC. Good idea.
yeah.
Yeah, of
Like the
course.
and by the way, the RFC goes beyond Spiffy. There's like more use cases in OIDC
Right.
related there. Yeah. So yeah,
And we can
there's
also have
okay.
the MTLS one, right? This
Yes,
is
we
what I'm
can
saying.
exactly both external and between components. I'm gonna add everything. Great idea.
Yeah. And outside Spiffy, without Spiffy at all. With
Yes,
the
yes,
Kubernetes, right? This should be also in the RFC. Hey,
yes.
there is also this native alternative, easier, like Eric has said, and it should be there for everybody to see. Thank you,
Yeah.
Eric, for joining.
Yep. So it's actually spiffy in all the use cases, workload identity, TLS with external and internal, and there's also Kubernetes service accounts tokens for what's missing, container registers basically, and also GitHub or IDC for Flux push artifact, like we did in Flux Mirror. So
Yeah.
all of that.
I mean, also these certs, right, that are provisioned by Kubernetes, they are based on the service account, right? It's the same underlying identity. This thing
I
that
think
should.
actually they support so tokens is only for service accounts, but I think their X509 PKI is service accounts and more things like users, like when
Oh,
you
users.
like
Yeah, of
in
course.
kind, like when you do a create a kind cluster, I think what you get is a cert with your username or something.
Oh, yeah, of course. Yeah.
Yeah. Yeah, it's the biggest RFC ever
Yes,
wrote. Like,
and not approved. You are not supposed to work on it. You are only supposed to think about it at this stage. Only small proof of concepts. Cool. I think we are over time. We are going to talk about Flux 10 year at the next one with the US people next week. Okay.
All right. Cool.
Thank you, Kingdom, for joining and listening to our crazy rant around TLS.
Yes, of course.
How are you, man?
I'm doing all right. Everything's pretty good. Busy as heck.
Easy.
We have a light LLM instance now, and
Oh yeah. You say it on Slack, right?
it's
Yeah.
scaling up. We're not in production yet. We only have one HGX H200 node, but um, I think we resolved a lot of performance issues, and we're definitely above 5 users now. We're approaching the 20 user threshold that I thought would be our next ceiling. But how many concurrent users, I can't really say. I don't know. We don't have enough Prometheus
Kingdom.
metrics to
So hear
establish
me
that
out.
yet.
What can we? You are using now the Flux UI, right?
Yes.
Do you see this deployment there with like we added now logs? You can actually
Yeah.
pick in the logs of the
Yeah,
LLM.
I saw you had a conversation with someone about the permissions. I guess the default permissions don't include logs, which makes sense. But when I went,
Do you have other buttons like delete pod?
I didn't have other buttons. It was the
Oh,
default
okay.
read-only
So if you
permissions. But
don't have buttons,
well, when I went
uh,
in, I wanted to create the configuration for OIDC, even though I don't have OIDC ready yet. I wanted to go through all the workflow, and I did wind up creating specific read-only permissions that did apparently include the log. So I have seen the log feature. So the user is still read-only, but they get access to actions, if I understood the conversation, depending on how you write the read-only role.
Yeah,
Was
you
the
can give
default
it.
was the
You
default
can
read-only role meant to include logs?
no.
Well, it didn't, so that's good. I agree with that decision. I was a
No, no,
little
like
surprised to see
hear
the
me out.
logs
So we
button.
have we have the concept actions, no actions.
Mhm.
If you don't configure an impersonation of a service account, at least of one service account, not necessarily DC, at least one service account you have to create yourself and assign to the to Flux operator. If you don't do that, and Flux operator runs only as cluster admin, by default, you have no actions
That's
because
what
you
I
are
did.
cluster admin.
I
And
created
that's
the
like very dangerous.
basic anonymous config from the docs, and I got the logs button.
Yeah. Yeah, but by default, you'll not get it.
Yeah.
That's, I mean,
Logs
people
are
are saying,
dangerous. When I noticed
people
that,
are,
yeah.
but it's read only. Man, it's not read only. It's yes, it's read only. You read the logs, but the logs always have, all the bad stuff in there. Like we can't allow that stuff. You have to opt in into it. So yes, you can say I'm not allowing people to reconcile, to delete pods. I'm only allowing them to read logs. Great. You
Okay,
can do that.
that's why I didn't speak up when I saw that conversation happening, because I thought that was probably an intentional decision. Don't expose the logs unless someone has configured it that way
Is
on
opting
purpose.
in.
Yeah.
Yeah, so we have that. But hear me out. It's like besides that, like you give them logs, but can we do something better in the Flux UI for when you are going to this LLM deployment, that dashboard? I'm thinking, so the main dashboard?
Yeah.
If you go to the main dashboard, then you expand a controller in that grid, you'll see that we have metrics, right? You see that?
I don't have metrics in there. I have status.
No metrics, right? Oh, you don't have metrics controller installed on the cluster.
Metrics server. No, I don't have metrics server on
Metrics
this
server.
cluster. Yeah.
Yeah. So you need to put metrics server on the cluster and you'll see metrics.
Okay. Cool.
But we only show them for the Flux controllers. And I think it will be useful to show them for the pods in the workload dashboard. You expand your app now and you see the pods, right? You can expand the pod, you see the container. You have the
I was
log
thinking
button
about
there.
something these days. What if we had a way to build dashboards from Prometheus queries? Let's build Grafana inside the from
No,
QL.
we can. Uh, a
No,
lot of dashboards do this. A lot of apps do this. You can just pre-bake some metrics that most users will appreciate. And when you install Flux operator and enable the UI, you say like in Flagger. You can give it the Prometheus identity. It can be a remote identity, workload identity. You go to hosted Prometheus, or you go to Prometheus proxy or whatever inside the cluster and so on. Flagger does all of that, and it's very easy. The code is there. It's like instant. We get Prometheus connectivity instant, and we can build in the workload dashboard things that are more complex from Prometheus metrics. But metrics server, which I think is like in 99% of the clusters, because otherwise HPA does not work, right? You need metrics server to do horizontal pod autoscaling. So it's everywhere. GK comes automatically with it, K3S and others, right? So what we do right now, we look up through the API if metric server is available. If it is available, we query through Kubernetes RBAC, through our identity, and we get the metrics for our own stuff, for the controllers. But we can use the same thing and show in the workload dashboard pods, CPU, memory, all the things that metric server, like the basic things that you expect to see when you look at the pod, like, is it 100% CPU? Is it 90% memory and that's why everything is shifty but is not restarting? Because that's, like in Java and other language, that's the hotspot where it's not at 100%, it does not restart, but it's very close, so the app is completely freezed. Right? So that you can only see from by looking at the metrics. So we can actually start with these two, CPU and memory for starters.
If you
Of
can
course,
compare
you'll
the
be
metric to the request or the request and limit, that'd be great. So I can see that it's pegged at 100% because the
this
metric
is
is
what
only going to show me it's at 600 millicPUs. It's not going to show me that the request and limit are both 600 millicPUs.
okay, install metric server and you'll see, like, or we already do that. We don't show you,
Oh,
we
cool.
show you
Cool.
98% calculated from, because we have the pod spec, we know limits, requests, we can do all the
that's
math. The
exactly what
math is
Camille is
already
saying.
there.
Yeah.
Nice.
We have built
Yeah,
this from
so
day zero. I mean, I want to see this about Flux. By now I'm realizing, why wouldn't we show this for everything now that we have like this workload view? And that will improve the experience of, I'm not just browsing pods, I'm actually seeing if they hit some limits.
So
Of course,
metric server only gives you instantaneous statistics, though. I'll tell you what I'm going to do with VLLM and the metrics that come out of VLLM. Because we want to run the biggest model that we can, and it takes up all 8 GPUs, we're going to monitor the utilization over time so we can tell if it's idle. And we have a separate voting dashboard where you can say, this is the model that I want to use. And keep your tab open so that you get a browser notification when that model's ready. And in the background, we're going to look at the utilization, and we're going to have more machines eventually, and we'll have more models too, so this problem doesn't go away.
Can you do this with the Prometheus and push gateway?
We will do Prometheus scraping. Yeah, we're gonna see whether the models are utilized so that we're not going to interrupt anyone who's actively doing work.
But in this case, it's reading, right? Not pushing, like.
We are going to push metrics because of the way that our network topology is set up. We have to expose Prometheus on the internet and then push metrics to it.
Yeah, it's
But
the push
are you
gateway. It's
gonna-
very common.
Yeah, but you're gonna use the push gateway where you like push the metrics there, or are you gonna expose the endpoint for screen? Like it.
No, we're going to set up an agent in the cluster and push. I don't know how it works yet, but if push gateway is what I have to use, I'll look that up.
Yeah, it's like, look it up. It may solve your problem because it's the invert of what Prometheus does, right? Instead of coming to you, you are sending data to it.
Yeah, I really want to set up labels and scrape from labels. I think agent will let me do that if push gateway.
Yeah, you just have to
can
be
help me
careful
not
a bit
expose
with
my whole Prometheus. That's what I want then.
You have to take care in some situations with the metrics, like it's not quite simple to use push gateway seamlessly like it is when Prometheus is pulling. Like when Prometheus is scraping is awesome. When push gateway, you have to be careful.
Yeah, you need to configure all the metadata,
metrics.
right? Yeah,
you have to
it's more work,
reset
but
in some scenarios. Yeah, it's quite complex.
Yeah, it's not built for that. But anyway, you can also use like what Cortex does, where you have Prometheus agents in the cluster, not Prometheus, without storage, without nothing. It's just a proxy. And Prometheus is isolated, it's in your cluster, scrapes everything from the cluster, so you don't need push gateway. But then push the data from this Prometheus agent, and it's like open source. Grafana has developed on, I think it's also in the Prometheus.
So in this case, it takes care of all the madness of
and you can set in each cluster in the agent once this kind of extra metadata, the cluster name, whatever, and it automatically labels all the metrics that it sends to the aggregation to where the actual Prometheus manager instances, main instance.
I think that's what I had planned to use.
Yeah, that's the better solution. Like push gateway is old school stuff. Go with a Prometheus mesh, basically agents, and that will make it easier for your labeling needs because you need to label everything. Like you also need to label your what model it is, whatever, what hardware, what, right? You want all that visibility into your dashboard, right? You're building your own UI basically for this, right?
Well, the front end that I have, it has a back end that's in Python that will consume those metrics. But the front end is really just about the voting. It doesn't expose much about utilization, not yet. We'll probably do that with Grafana. So there'll be a Grafana dashboard you can go to see all of the details. But
Right.
if you just are interested in the election status and when my model loads, then that's what the UI is for. So you'll have to be in the majority of people who want a model for your model to load. Otherwise, the model doesn't load. We'll just keep the model loaded that people voted for. So
So people can vote
we
for
found a little gap in what Light LLM can do, right? It lets you switch between models, but it doesn't like. I mean, you could probably set this up with Kada if your observability pipeline is really good. We're not there yet, and the scale to zero isn't practical because the scale up is slow. But all of those are solvable problems. We have 2 TB of RAM. We can load the models into RAM and they'll load that much faster. Um, it's just an order of operations thing. When we have one piece of hardware, a lot of problems are unsolvable.
yeah, yeah, you need to build your own automation and observability before hooking all these tools in,
Why
right?
I see all these Twitter people say, if I could just get one more DGX Spark, then it would be perfect. Just need one more, man.
Crazy. Yeah,
But we have
yeah,
the same
it's
problem on the Raspberry Pi cluster. We have a Halo 10H that can do like 10 uh, token operations per second. Like it's a tiny machine that fits on a Raspberry Pi. It can only fit one model at a time. If we want to switch between models, there has to be some sort of coordination for that. And it shouldn't go through a sysadmin who has to personally approve and implement the model switch. Um, so on the back end, that's happening with GitOps. We have a Git branch per deployment profile and just switch Git repository source when we want to switch profiles. A machine can certainly do that. We already have the AI agent skill for admin election. So we just need someone to man that at this point, and soon it will probably be an agent that is unmanned. Just decision about whether we're switching models too frequently or not, and occasionally,
yeah.
yeah.
AI is also very, very good at this if you get it to collecting some data. Let's say after 6 months of using the system and digging manually and so on, if you actually have good metrics around when we change, why we change, all the change system stuff is recorded somewhere. I don't know, Word
Then it can
document,
start doing
whatever.
predictive changes for
Uh,
us. Yeah.
yeah, Git issues, GitHub issues, right? And then you say like, look at all this stuff. And now figuring out how to run it smoothly based on all this history, it will do a great job. If it does not have a history, it will propose something that can or cannot work, right? But yeah, it's best if you have some historical data always.
Okay, I think I'm probably missing the Cozy Stack meeting that started a few minutes ago.
Cool. Okay, we are off.
All right.
Thank you very much for being here. It was nice meeting you all. Bye.